Good morning, everyone. It's Bob Martin, the RCSubGuy, here with Logan at the Nautilus Drydocks. It is January the 2nd. Happy belated New Year to everyone. Let's get the week started. So we are kicking things off with a bang here. We got a couple of projects that we are going to be working on, trying to get knocked out so we can get to the big ones. We tested our Thunder Tiger over the weekend, and things did not go super well. So you can see that Logan is disassembling everything, and what ended up happening is the ballast tank actually did work. The new ballast system did actually work. It got the water level down to about here. That wasn't sufficient. We're going to need to add a little bit more ballast weight, which is actually fine because it's floating really high, to be honest with you. So that part was good. The bad part was, continuing to try and cycle that ballast tank and get more and more ballast in. With no pressure switch or limit switch, the pump just got in and it I assume it blew a hose. So we're going to see exactly what gave out in here. Pumped a little bit of water into the bottom, but because of the design of the boat, there was really nothing to get wet. It was just a big empty area in the keel there. So we were taking it all apart. Again, I think this is about the fourth time we're going to have it all apart and see what's going on. And then we need to figure out how to make sure we don't rupture a hose or pop a fitting or whatever has ended up happening in there. I am working on some batteries. We're going to get to that in a moment. I'll show you how to do it, but this is going to be a 12 volt, 5 amp battery pack, and there's going to be 2 of them in here. So I'll show you how it's done. I've done another video on that in the past, so we'll go into that. More work on Seaview. Got the baffles for the ballast tank all printed out. We're going to install those, have the baffled ballast tank, and then seal all that up ready for wiring. Pretty excited because we're now getting to the point where we can breathe the life into this boat. Logan's going to be continuing work on the 48-inch Nautilus and wrapping up some 3D printing projects. So we got the last of the bridge module. This is what it looks like with all the supports in place, like a forest of supports, but they break out really, really easily. That's got to get bundled up. That customer also wanted some of my fancy new intake louvers on the back there. So we're going to print those out. Those are on the printer right now, and then we're going to bundle it all up and ship it off to him. And this week we'll be playing with torpedoes. Hopefully getting a launch. We'll see how the week goes. But, of course, this is a short week because it was New Year's Day yesterday. And we kind of tapped it cool, other than replying to emails and working on some stuff like that. Some 3D files. Not a lot got done yesterday. So, with all that said, let's take a look at this battery pack situation. So, I don't know if you know or not, I assume most of you do, when you get a battery, it is typically composed of cells, and that goes for lithium polymer battery packs, NiCad battery packs, nickel metal hydride battery packs. They are all composed of cells. Now, in this particular case, each cell of this 12 volt battery pack is a standard C-cell nickel metal hydride battery pack. With a positive and a negative. Each one of these cells is 1.2 volts. So if I put my voltmeter on here, you can see we're at 1.29 volts. So the way that you get your 12 volts is you put these all in series. And so 2 of them together would be 2.4 volts, 5 amps. 2 of those double battery packs would be, what is that, 4.8 volts, 5 amps. The other way of doing it is in parallel, so you would connect all of the positives together, and that would give you 1.2 volts, 10 amps if you put 2 of these together. So what I've got going on here, I've built little sub-assemblies. So this is the individual cell, double cells. Now, again, if what I'm telling you is correct, then, in theory, if I can manage this, I'll hold the meter on here, 2.58 volts. And I put 2 of those together to make a quad pack, 5.16 volts. Now, if I put 2 of those together, which I'm going to do shortly, it would be double that voltage. So the way that you do all of this, you use these little tabs that you get, and you solder them across the terminal. So you go positive of the one pack to the negative of the other pack, and you just put it like this and solder it in. Careful not to overheat the battery. Now I'm just using a standard high output 70 watt gas powered solder gun. The proper one is it's like a spot solder. It's exceptionally high temperature in a very, very focused area, and it's like zoop, and it solders them together. If I built a gajillion of these battery packs, I would certainly invest in one of those. But where I'm at right now, I've just got to take 2 of these quad packs, solder them together like this, add a double at the end, and then tape and heat shrink and run the wires. So let me show you what the soldering of those tabs looks like. Okay, so the way I do this is I put just a little bit of liquid flux on the ends of the batteries here, and then I pre-tin the ends. So I'm just going to grab my solder here, wet down the tip, and then quickly press it down, let it heat up, give it a little extra, and that's it. As soon as I see it pool nicely, I know that it's adhered properly. So I'm going to do the same thing here. Just let it heat up until it kind of pools, and then pull it away. It doesn't take much at all. Now I'm going to take my tab here, straighten it out, and I'm going to, this is kind of important, I pre-tin the tip of my gun so that when I press this on, the heat is transferred more efficiently via the liquid solder on the tip of the gun. I'll let that loose. Actually, got a little goober there. I'll just straighten that out. There we go. And then the same thing right here. And that's all fused together now. I can trim the excess. And now if I fold the battery pack together, keeping it on this flat surface, keep it tight together, I can tear off a little chunk of tape, put it on the joint, keep it tight together, and roll it together like this. And now we've got, what's this, 8 cells. One more double on the end, we'll have the 10 that we need, multiplied by 1.2, gives us 12. All right, so Logan's got the Neptune disassembled here, and something I wasn't expecting. What's the story?
Turns out that the envelope exploded, not any of the hoses, which is really surprising because you can see how well built. Actually, this isn't actually.
I wonder if that was a flaw in the manufacturing, because I don't know if our little gear pump would have the pressure to blow through that.
Not to mention it's blown through in multiple areas. I can see a break in the manifold over here as well as the main here as well. So I think it's honestly just held together with adhesive.
Yeah, it is. It's pressed together and fused with a nylon fabric shell on the outside. Interesting. Well, this is a chance for yet another upgrade. I've got a 500 mil, I think I do, air bladder from a pressure cuff.
We've got a lot of air bladders sitting around.
Yeah. So we'll do we'll do that. Let's go grab one of those. We'll pull this thing out and replace it with a high-strength rubber bladder. All right, as you can see, we got the entire battery pack done. I've double-checked. We've got a full, actually it's like 13 volts, because a fully charged battery, by the way, like a sealed lead-acid battery, nickel metal hydride, it's going to be closer to like 14 volts, fully charged up. So we got good continuity in there. I soldered in wire leads, because obviously we need a way to get the power out of the entire battery pack. So we've connected each of the ends. Negative to the negative, positive to the positive. And now we need some heat shrink. I got this off of Amazon. All right, I've already got one battery pack done. And you can see that in there. And I'm going to show you how I did the second one. But you can see what the final one looks like right there. So what you want to do is take your heat shrink. Now, if you just try and stuff the batteries in there, because the inside of this heat shrink is a little sticky, you'll never ever get those batteries in. So just use a little bit of silicone spray and shoot it in there, kind of massage it down the length of the tubing like this. And now the battery pack will just slip right in there. And at this stage, you want to make sure that you're really gentle with these battery packs. It's really important to use this tape to keep everything together and in line there. So now you can see this just drops right in there really easily, like this. And now we can go on to silicone. All right, got the battery pack in the sleeve, and I've trimmed it off. I just had a little bit extra there. I'll throw that away. Wiped out the interior of it so that the silicone oil is not there. And now I'm going to take some clear silicone, and I am going to put a huge gob all the way on the inside there. And you can be generous, because anything that isn't kind of used will end up coming back. I'm just going to push that against the battery all around the wire. Now I'm going to do the same thing on the other side, and this side's more important because we've got two perforations in terms of wires here, so you want to make sure the silicone goes all the way around the wires. All right, there is the silicone plug that we've got in the end there, and I am using a propane torch, and the reason I'm doing that and not a heat gun is you want to make sure you put the maximum amount of heat in the minimum amount of time. If you don't have a high heat output source, then what will end up happening is you'll just heat and heat and heat and heat, and your batteries will end up getting cooked. So that's why I like using the torch. Obviously, don't get too close. Don't set on fire or anything silly like that. But I'm just hanging this off the edge. I'm going to heat this up until it sandwiches around the battery there, and then I'm just going to hold it up and then redo the whole thing. And while it's still warm, we're going to set it on the table so that the level surface makes a perfectly flat battery pack. So here we go. We got the two battery packs here side by side. Obviously, that's the business end, and you can see the wires are floating inside there. Now, you'll notice I got white silicone on one and clear on the other. Now, the reason I did this was not just because I ran out of white silicone, but because he's going to be running a twin battery pack, which is going to be 12 volts, 10 amps. All right. And I want to offer him a way to differentiate battery pack 1 and battery pack 2. And this could be for diagnostic purposes, maintenance purposes, and everything like that. So it's just a quick visual indicator of battery pack 1, battery pack 2. Both the silicones are going to work equally well. It's not a big deal. The other thing I wanted to note here, this is obviously a little bit more than what was probably needed, so this can just be cut straight off and trim the battery pack length down a little bit. But for now, we're just going to let that heat shrink solidify, and then battery packs will be nice and firm, locked in, ready to go. I'm going to ship these with the leads unclipped so that there's no chance of short circuit. And yeah, this project is done. All right, Logan has swapped out our faulty ballast bag, and this is a little smaller than I thought it was. But what we've swapped it out for is an actual blood pressure cuff. So this is what we've got going on. This is the guts of the boat. How hard was it to swap that out?
Not horribly. I mean, snip one or two zip ties that are attached to a few cables. Once you pull those off, you just replace it.
And did you re-zip tie the connection?
Zip tied.
Cool. So yeah, this is a rubber bladder. Now this is adult sized because it's the only one that I had here. Now what would probably fit better is a child blood pressure cuff. You can get them on eBay and stuff like that for super cheap. But I had this, and there's no reason it wouldn't work. We tried it with air just by blowing into it, but we're going to try it with water now. You can see these fancy test setup that we've got. So, okay, go ahead, power. Okay, you powered on. Let's turn on the boat. Okay. All right, so we've got power. So let's go. Let's blow it first. So stick left. We'll suck all the air out of it. Oh, a little more. Okay, good. So that no more air in there. So this is completely empty. Now we're going to go the other way and see what happens in real life when this thing just goes and goes.
It's a robotic drinking machine.
Mm-hmm. Okay. So that is completely full. And I'm going to be willing to bet that's at least half again as much ballast as this thing offered, which is why it took so much longer to fill. So let's cycle it empty, and then I want to time how long it takes to get to full, so that when we run in the pond, in the pool, we don't overcycle it, if that makes sense.
Yeah.
All right, empty that sucker. If we were to swap out this radio for a FreeSky,
Yeah, do that.
you could actually set it so that when you flick the ballast button, it would start a timer, and you can have a countdown. So if it, say, takes 20 seconds to cycle, it'll do a countdown, and then when you stop it, it'll reset. So that would be a workaround possibility. Of course, it would be a better radio too, but it's also a $300 radio, which would add a lot of cost to the boat. And right now this is working. What I do like about this is that unlike the old nylon bladder, which is basically super like rigid, when it reaches capacity, it reaches capacity. And they probably designed it that way on purpose. But there's nothing in here that's going to get harmed by this over-pressurizing. It's like a balloon. It just kind of conforms to what's inside. So again, provided we don't just go, I think we'll be all right. So let me grab my phone, and we'll time this. Are you ready? 3, 2, 1, go. And stop. 25 seconds to fill. Now I'm interested if it's 25 to empty as well. Okay, so 25 seconds, reset, and go. Ah! The force of that big Chinese pump. Okay, go. Good. Actually took a little longer. It was like 30 seconds going the other way. But I think that's pretty in line with the old peristaltic pump. But now we've got probably half again the volume, and it's got give in it, so it shouldn't, hit the end and then burst if we accidentally overpressure it or whatever. So
That also fixes our weight problem.
yeah, we don't need to add, hopefully we don't need to add ballast weight to it, because we'll be taking on a little bit of additional ballast that's precisely centered in the middle of the boat. So now you get to put it all back together again.
Yep.
So as you can see, we are outside again in the cool weather, but it could be worse. Neptune's back in the water. We've not yet tried the ballast system to see what happens. I did a little lap on the surface. Everything is looking good. I'm just going to go bring it into somewhere in the middle here so you can see. It's got a nice tight turning radius. I'll have to, these things turn like nobody's business. So we're going to see what happens. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We got a leak. I can see bubbles, but
It's lower.
yeah. Now we got it. That's got it. There's bubbles coming from somewhere. Okay, we are back outside, and you can see Logan has stripped the body off. It actually floats really, like, level. That's cool. All right, but we need to find out where this massive leak is coming from, and the beauty of this design is we'll be able to see precisely where it is. All right.
Fun thing is you can also watch the bladder fill up so we can see if it's still...
Yeah, there you go. All right, cool. Let's dive. Bladder's filling. No bubbles yet. Oh, there's the bubbles. All right, where are those coming from? Looks like underneath. Oh, it's the seal for the power switch. That's exciting. So it is just after lunch on Wednesday today. Half-ish way through the week. Not a lot of like little stuff to share because we just got two big projects that we're working on mostly. Logan's making good progress on Nautilus, getting the body sections all put together. Yeah, you're going to be doing some LED lights there pretty quick, and did a pretty cool job. The customer wanted to have a little map and a little compass on there, so Logan built a little, gosh, I'm going to say that's like 4 millimeter long compass. Looks really cool. After we get all of this body put together, we got to take stock of our little parts and see what I need to reprint. Because we broke some stuff and we lost some stuff. I got a little happy with the leaf blower when we were cleaning out the shop, and I blew all of our little parts into the driveway. Really good projects or progress on Seaview though. Again, most of the specifics are all going to be in the specific video for Seaview, but the watertight box is, as far as I know, done. I haven't checked it for watertight integrity. But it should be good in theory if I know what I'm doing. It's got a little mounting bracket there that will have a little loop of Velcro that'll hold it down. The battery's all done, all wired up. The ballast tank is all sealed up, and the solenoids have been installed. I've marked out the vents for the ballast tank, and I paired the radio. So everything is hooked up and working right now, except the solenoids, because I'm just waiting for the RTV to kick off and cure. But yeah, this is going really good. What I need to do right now, though, is source a pressure vessel for the butane gas backup system for the ballast tank. So if the boat ends up going down, takes on some water, and loses positive buoyancy, I want to have a backup system in there. You can give it a little burp, bring it back up, and then use the low pressure blower to blow out the ballast tank. That's the plan, at any rate. And the air pump is doing some weird things. It sounds like it's an old Harley with a big cam in it. It doesn't sound proper. I got to pull it out, run power direct to it, and see maybe if it's the relay not giving it enough juice or what. But at any rate, really good progress. I'm really happy with this. We're gonna go hardcore on this and see. We may get to trimming this week. We'll keep our fingers crossed. Back outside. 10th tries the charm for our Neptune. Logan gutted the old seal and replaced it with a new cup seal. And that was a bit of a project.
Yeah, it took me about an hour.
Yeah, I had to drill it out and make way for a new assembly. Of course, this is all metric, which I love, but we don't have any metric stuff available to us, and so we had to drill it out for 1/8, and I think you can see the new seal right underneath there, the little brass body. And now this sits just a little lower, so actually it's easier to get at. And there's our little dude. I just love our little dude.
Just like in hand.
He's doing a incredible job. All right, on, working. Okay, dunk that sucker. Let's see what happens. So far, so good. That's it, eh? Bag's full?
Just about. You can probably go for another like 2 seconds.
Yeah. Yes, I think we got it.
Decently positively buoyant at the front.
Well, it's missing all the weight of the hull and everything, right? And the weight of the sail.
Yeah. That's a tight cylinder. With water.
Mm-mm. All right, well, bring that sucker back up and throw the body back on, and it's going to be done, ready for some kind of a lake trial. I am going to be playing coach, but Logan's going to be doing all the work on Nautilus. Lots of things going on there. We got Nemo getting printed. And then you're pretty close to sealing up the wheelhouse, right? What else is left?
We're missing from the wheelhouse. Once we get Nemo and the spare crewman.
The little map.
Right. I think it's just the maps. After that, we need replacement breathers because we're missing one.
And one of them got chipped or something too, right?
Yeah. I mean, they're all a little damaged, and they all have these, like, pock marks on the back.
Yeah, we'll reprint them so they're perfect. That was like a bulk print, and it wasn't kind of properly set up.
Yeah, same thing with these vents. This one in particular is probably unusable, but we've still got all the rest of these vents.
Okay. So Nathan was just out here and showed me a bunch of radio stuff, and now I am super excited about what we've got going on here. I'm going to plug in our boat, and I'm going to do a little show and tell. Power's on, lights are on. The other thing I want to show you, I've got this this cool unit called a Watts Up, and you plug it in between your battery, and it'll show you current draw, voltage, and all sorts of cool stuff. I am interested to see what the current draw of the boat is with the various functions. So we're going to take a look at that. So right now, just the LED lights and the other lights in the back there are drawing about 230 milliamps right now. So good to know. Got the radio turned on, so I'm gonna fire up the boat. So in idle state, we are at 0.42 amps, so 400 milliamps in idle state, and that's basically the receiver sucking power, and the other ESCs just in quiescent state. So taking a look at this when we move it, servos don't really draw anything. I'm moving the servos right now. They're not drawing anything hardly. We're still at about 350 milliamps. But I'm interested to see what the ballast system does. So I'm going to turn on the air pump. So that's about 1 amp, which would be, I guess, about 600 milliamps. That's not bad. I can live with that. And now the vent solenoids. 1.3. So that's about an amp. That's not bad either. I can live with that too. And now we are going to fire up our throttles. So that was about 2/3. Got up to, what was that, about 1.6? That was like 3 amps. So, I mean, obviously in the water it's going to be drawing a lot more than that. But really just what I'm looking for is to understand, the current draw and what the various components of this thing actually end up sucking in operation. Now, I want to show you what I ended up doing here with the radio. Now, what I wanted to do, the way I've got this set up, I've got each of the throttles set on an independent potentiometer here right now. So if we take a look in the back there, I don't know if you can actually see them moving. Interesting, maybe. So if I move, there's our right motor and our left motor. So I could say, for example, put the left motor full forward and the right backward. And that would create torque about this point that would, in theory, spin the boat. Now, do I think it's going to work really, really well? No, it's not going to. They're too close together and it's too big of a boat. But would it get you out of a bad spot? Yeah, I think it probably would. So that functionality is in there. But of course, you don't want to drive this thing having to work each motor separately. So what we've got rigged up now, you just flick this switch, and now the throttle has linked these two together, and I can use just this stick in forward and reverse. So this would be normal operation, normal throttles, and then if I want to do the steering, just flick the switch and these come back in. And of course they're locked out when the switches are in the other positions. So that I thought was really cool. The other thing that we got is a live voltage readout of the main drive battery. You can see this is reading 12.2 and 12.24. So we got a live readout of the voltage of the main drive battery. And the other thing I got set up are some timers. So as we saw, the air pump and the vents do take a not inconsiderable amount of voltage or current when they're operating. And being that it is a 3-position switch, it could be that you dive the boat and then just leave the vents open by accident. You don't want to do that because it'll be sucking an extra, amp of power that you don't need to be spending. So I've got this set up. So for example, if we were to dive, we would want to move the switch down, dive. Now we see a timer has started. And based on our calculations, it should take approximately 1 minute to vent. So I've actually got it set up where at 1.5 minutes, if you have not returned this switch to the center position, the neutral position, an alarm will beep, reminding you to close the vents. Now you'll see when I put this back into the middle, that vent timer resets. Similarly for the air pump, if I activate that, the timer starts. And resets when I return it to 0. So just a couple of really cool features that are built in to these new radios. It's just a matter of programming everything in. I'm excited to see how it works, and you can obviously modify those timers, so set it almost exactly. So when that tank is done venting, you'll know, let's say it takes an average of 64 seconds, you determine it takes. You could set that timer to 70 seconds instead of the 1.5 minutes. So it's safe right now. Worst case scenario, you'd be running for an extra 30 seconds or so. We'll see. Hopefully that's the case. But other stuff that we've done on the boat. All right, it happens to be Friday here right now, and we have put the Nautilus away because I've got super awesome news. My supplier overseas for those 48-inch Nautilus kits came through with a great quote. We've got one on order to ascertain quality, which based on my last order for them for the Shark is going to be awesome. Because these are big commercial grade 3D resin printers. So the good news is we're going to have, hopefully, 48-inch Nautilus kits to offer here in the near future. So that's been set aside because we are going to probably, for that build, use the new parts. If not, we've still got them to fall back on, but for now, we just set it aside. We're going to work on Seaview this morning and going through the Calypso, getting ready to ship that. Should be a good day. So we're outside. You guys have seen the Odyssey with the Calypso. Fortunately, it got sold to a gentleman in Italy, and we're just going to put it in the water, make sure it floats right, and make sure it operates correctly. So I'm just going to toss it in the water here. We got a little list to starboard. It looks like we maybe need some weight up on this side. Maybe I'll go grab a weight and we'll maybe put it right here and we'll see if we can get it floating level. So it's in the water, it's floating level. We just added one little weight to the port side, and in theory, it should work. A third throttle. Let me get it pointed here and I'll goose it, see what happens. It'll move. Boy, reverse really doesn't do much compared to forward. Well, that'll about wrap it up for this week. It's Friday the 5th, and we are shutting down. The sun's come out. That's good. It was all sunny before. Rainy before. I'm really happy with progress on the Seaview. I think it's going to turn out really, really good. Once we get all the parts that we need for this thing, this is going to be wet next week, for sure. We'll be trimming, checking all the functions and everything, and then after that, it's just cosmetics, and then final testing. So I'm thinking next-ish, weeks-ish, we'll be done that, and then heavy on to Seahund. Because both of these boats are going at the same person.
Calypso in a box?
We stuck Calypso in a box. Yeah. And we tested it, as you just saw on the video. That was actually fun. That's a good-looking boat.
Yeah. I mean, it was really maneuverable, too. I mean, it's not good for turning around in, like, 6 feet, but put that out in the water and it'll putter around nice.
Yeah, it was super interesting. The props are really, really efficient in forwards, but probably only like 20% efficient in reverse. And it's equal RPMs. I checked that. It just doesn't like going backwards. So new owner's just going to make sure he doesn't go head-on collision at the shore or rock wall or another boat because the brakes don't work so good. But not a problem if you're careful how you drive your boat. Any parting words or comments to anybody?
Can't think of anything.
Okay. All right. Logan had made a comment about custom work. We do like standard builds and all that. Like each build will have its own standard scope of work. And customers always reach out with like weird things that they want. And the answer to whether or not we can do it is always yes if you have enough money. Because all that custom work is like an exponential increase in the amount of time that it ends up having to incorporate it and research it and implement it and do all of that stuff. So just bear that in mind. If you're looking to contract with us for a build, it might be best to do a standard build. And then later on, you can add all the bells and whistles that you want. But some stuff is fun. Like you're enjoying the Nemo thing, right?
Yeah, it's been interesting cutting up figures and reassembling them. And we only really have Nemo in his salon outfit. And since we're trying to build him for the helm, it doesn't really make sense that he's sitting there in his salon wear driving the boat.
His smoking jacket.
Yep. So we're trying to restructure it to give him his classic captain's outfit minus the hat, which we don't really have anyone with a hat.
And his hands need to line up with the ship's wheel too, which makes it challenging.
So we've kind of like cut him to pieces because the crewmate who's manning the wheel is wearing the like rope-tied sandals, which is actually a fun thing if you want to look up. Next time you look up 20,000 Leagues like characters, some of the crew members who were running around were wearing these sandals with like
big hemp ropes, like 3/4 inch diameter hemp ropes,
which we found kind of funny. And we don't want the captain sitting up there doing that, so...
No, that's not very stylish. That's not Nemo style, for sure.
So we swapped out his salon legs with a crew member's chest, and then his head.
Yeah. But, again, someone's just a simple thing is like, oh, I want, Captain Nemo at the helm. Well, we could have just glued Nemo in his smoking jacket in front of the ship's wheel, but it wouldn't have made sense. And so now it's, cut and glue and position and fill and sand and all that stuff. But it's all fun. It's all challenging, but it's time. And just bear in mind, that's when you ask us to do stuff like that, it's going to come back to you in the end. We will catch you guys next week. As per usual, if you like what you're seeing here, like and subscribe. It helps us out a lot. You can always drop comments. I check them as I can, but bob@nautilusdrydocks.com is a faster, more efficient way to get a hold of me. So I'm going to leave it at that. On behalf of myself and
Logan.
have a great week. Catch you next time.